20 molar C2H5NH2 solution with a Kb equal to 5.6 E negative 4. Okay, calculate the percent disassociation. I know that percent disassociation is equal to X over the initial amount. And the initial amount's given, which means I'm solving for X, which means I'm going to have to do one of those equilibrium problems. So C2H5NH2, I can definitely see that this is going to be a base, which means I'm going to add water. It's going to give me C2H5NH3 plus for sure, plus OH minus. Okay, and they want X. This is just me rationalizing in my head. This is not really an explanation. So I know the equilibrium expression is going to be C2H5NH3 plus times OH minus C2H5NH2. And I'm going to plug these in for X. I'm not going to do the table. I'm going to just use law of assumptions that X squared over the initial concentration, which is 0.2, is equal to Kb, which they gave me to be 5.6 E negative 4. So then I'm going to plug that into the calculator. 5.6 E negative 4 times 0.2 will give you X squared equals 1.12 E negative 4, meaning that X is going to equal negative 4. X is going to equal 1.1 E negative 2. And 1.1 E negative 2 divided by the original concentration is equal, so X over the 0.2 is equal to, oh God, it's equal to 5.3, which does not meet the law of assumption. So I'm going to have to use a quadratic formula. So my ICE table says that my equilibrium concentrations are going to be 0.2 minus X and X and X. And the reason that's important is because now I got to actually manually solve for X. So Kb, once again, is 5.6 E negative 4, which is equal to X squared over 0.2 minus X. Now I have to distribute, so it'll be 5.6 E negative 4 times 0.2 minus X equals X squared. I have to use the quadratic formula here. Perfect. Okay. So in order to use a quadratic formula, I have to also switch everything to the right side. I'm going to move this to the corner. Okay. So quadratic formula. So we have the X squared. I'm going to add these to another side. So I'm going to distribute. And it will be that minus 5.6 E negative 4X plus 5.6 E negative 4 times the 0.2 again, which gives you the 1.12 E negative 4. So when we add that to this side, this should actually become a positive, and this becomes the negative. And now we have to use the quadratic formula, which says a negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so I'm going to have two solutions. The positive one is obviously going to be my solution here, right? Okay, so, sorry for the next, okay, so that means that, I'm gonna plug this into the calculator. So basically what I'm plugging in right now is this, negative 4 plus, I'm going to do plus because I need the positive as well. So 5.6 E negative 4 squared minus 4 times 1.12 E negative 4 over 2A. So all of this, once calculated, will be divided by 2. The square root of 5.6 E negative 4 squared minus 4 times negative 1.12 E negative 4. Oh God, my calculator just went to syntax. So negative 5.6. Negative b. Yeah, so when I do a negative b, that means that negative 5.6 E negative 4 plus the square root of b squared. So I don't know why I did that when I could just sort of just leave it. whatever, E negative 4 squared plus 9. I'm just gonna do plus because once I multiply these out, the negatives are gonna cancel. E negative 4 is gonna give me that divided by 2. Okay, and with all of this, you get that x is equal to 0.0103. Now that I manually solved for x, to find the percent disassociation, it's going to be x over the initial amount. It also feels like I'm checking for the 5% right here, but 0.0103 out of the initial amount, which is 0.2 molar. It's going to give you a value, 1 multiplied by 100, of 5.2%. And that is your percent. So when what the question asks, the way I would restate it is the percent ionization of a 0.20 molar solution of C2H5NH2 is 5.2%.